So, good evening, everyone, and good evening, sir.
Good evening, sir.
Good evening. So, I welcome you to the fourth day of this Space Week, World Space Week. And as you can see, the audience is literally getting low as we move on. Okay. So, this is what happens when we go on to a journey to learn something. At the first day, there was an audience of, I think, 50 plus. At the fourth day, the audience is around 10. Okay. So, this is what happens. Okay. This is the real engineering. Okay. So, coming to the topic, so we have our guest today as Alok sir. He has been a graduate from IIT, okay, and he's been a great science communicator in his field, and he's spreading awareness in the field of basic science and Indian astronomy. He has also developed an application for the for the Indian like Navagrahas and how to find out the basic uh, position of the gas and all sort of things. Okay, so yeah, so he will be guiding you that how we can learn the Indian astronomy and what is the significance of our Indian astronomy. Okay, so over to you, sir, and all the best, sir.
Okay, good evening, everyone. Let me start with sharing the slides. Wait. Can you see the slides?
Oh yes, sir.
Yeah, okay, so I'll start. So I'll talk today about Indian astronomy. So first, let's talk about astronomy. So it's considered to be one of the first sciences. So if you look at the history of man, maybe agriculture and astronomy were the first branch of sciences. How do we know that? So just imagine you are a prehistoric man. You gathered food, and before you even started cultivation, you discovered agriculture. What was it that you studied? You studied nature, you studied trees, plants, herbs, and all this. Other than that, during night time, there was not much you could do. So you could always wander at the sky and look at the stars, the Milky Way galaxy, and so many things. But you notice that there is day and night. There are seasons that go on throughout the year. You know that there is a year because after 365 days the same season cycle keeps on repeating. So that way, even thousands of years, tens of thousands of years ago, man was aware of astronomy as a basic concept. And there is the basic need of keeping track of times. Once we got into a agrarian society, it was essential to keep track of seasons, when it will it rain, when it will be winter, when it will be summer, to plan your crops accordingly. So that's how astronomy was first discovered. So the basic practical need of astronomy in ancient times was calendars. It's also relevant now, but since we use electronics, mobiles, and GPS and all that, so we don't need astronomy as such for practical navigation and timekeeping. But the basic idea of all this comes from astronomy only. So the image that you see here is basically an image of the Mayan calendar. So this, I'm not sure if you are aware of this. In 2012, there was all doomsday sayers saying that the world would end in 2012, and that was because the Mayan calendar is basically the last date of the Mayan calendar was supposed to be in 2012. So everyone that believed in that thought that this was the last year for mankind, and somehow the mankind would be destroyed in that year. So again, that's a myth developed because of a calendar system. So there are multiple calendar systems. That the one we use right now in our daily lives is called Gregorian. It's the Western calendar system, and the other calendar system are based on the moon. So the festivals that we follow in India, you see that they are not on the same day. So, for example, the Independence Day, Republic Day, we all follow on 15th of August, 26th of January. These are fixed date because they are celebrated on Gregorian. You perhaps celebrate your birthday on a Gregorian date. So if you're born on, say, today, 7th of October, your birthday will fall on the same day. But if you follow the lunar calendar, for example, Deepavali, you'll find that the dates keep on shifting every year because that is celebrated on the day of Amavasya, when uh, diyas and all are lit up to compensate for a lack of moon. So that Amavasya every year will keep on shifting. That's why. So anyway, so these are the types of calendars, and all are based on astronomy. So just give you a brief idea of how astronomy basically shapes our concept of time. So we have a day, month, and a year, right? All of this is basically given to us by our orbital parameters of the Earth. How so? So let's take one day, that is 24 hours. Anyways, hours in itself is interesting story how it came to be. But there is a day and a night. So combined, these two we call as a day, right? So that is basically because of rotation of the Earth. When we complete one rotation of the Earth, there is a cycle of a day and night complete for one location, right? If there is a day in one place, you'll have a night and in the other place. So that is day. Then I'll jump directly to year. Year is basically an orbit, complete orbit around the sun. So that what does change in the revolution around the sun? The season. So the only way we could decipher that we have completed one year around the sun in the daytime is because of the seasons. So if there is summer, then you'll get rainy season. Then slowly it will get cold, and after a few months of cold, you'll get spring, and then again summer. And you'll see that this cycle keeps on repeating every 365 days or so. But how does month come into picture? So day and night, and basically a year is all because of rotation, revolution, and it's to do with the light of the sun. There are 365 days, but during night time, if you see, the only source of prominent light is our moon. So moon goes through a cycle of full moon to new moon to full moon, Shukla Paksh, Krishna Paksh, or in English we call that waxing phase and waning phase. So you'll see that the this period is basically around 29 days. Okay, that 29-day period, if you just track the number of full moons in a cycle of seasons, you'll see there are 12 full moons. So that is how we get month, the concept of month. So if there was no moon, there might have been some other concept. But because of the sun, we have day and the year, and because of the moon, we have a concept of month. So this is a basic relation of astronomy and timekeeping. So I'll just jump directly to something called grahas. Okay, now the modern definition of planets. All of you in your school textbooks would have studied that there are 8 planets. In my school time, we used to have 9 planets. Pluto was also considered planet till 2006, although it was discovered very recently, 1930 or something. So it's a very recent discovery. Still, it was demoted from a planet to a dwarf planet. So because other than Pluto, we have discovered many dwarf planets, and the criteria that was defined by IU, now we define only 8 planets in the solar system. But the concept of grahas is something different. So if you look in the night sky, you'll see even in the day sky. So first of all, there are only 2 things possible to be seen with the naked eye in the day sky. That first is of course the sun, but when the moon is bigger, you can also see the moon during the daytime. So moon and the sun both are visible in the daytime, and in the night time, by definition, night is when sun is gone. The stars and other objects that you see. Okay, if you notice them day after day, you'll see that their position keep on changing, but their relative position. For example, if you see Orion or Kalpurush, that constellation will keep its shape. It will rotate and move around in the sky because of rotation of Earth. But if you look at it, even after 2 months, the shape will not distort. There is something that will move around with respect to the stars, and those we call as grahas. Okay, so I'll just show this image. In our Indian culture, this is basically an image of Navagraha Puja. Okay, you can see Shivling on top, and there are 9 basically deities placed, and there are many other variations. So basically, we worship in our Indian culture Navagraha, 9 grahas. So there was this misconception. Even many people still believe that there are 9 planets, so Navagraha. But how is it so? First of all, Pluto is not a planet anymore. So there are 8 planets. Okay. So the distinction here is planets and grahas. Planet is a modern definition. As I was explaining in previous slide, grahas is anything that moves in the sky. So basically, sun and the moon that also move with respect to the star. So sun and the moon are also considered as grahas. So that gives us sun, moon, and but that if you add up, that will give us 10, basically 8 planets that we have in solar system plus 2 sun and moon. But how is it 10? The problem is Uranus and Neptune. So these two planets basically have been discovered after the invention of telescope. Before telescope was there, Uranus and Neptune are very faint, so they are not visible to the naked eyes. Only with the help of a telescope you'll be able to see. So what does that entail? So this is another practical implication of that. So in our calendar, even in Gregorian calendar system, we basically have the concept of a week, right? We have 7-day week. Today is Saturday. Okay. So what is Saturday? Saturday is basically Saturn day, right? Saturn, and in Hindi we call it Shaniva. Shani is Saturn. So each graha has been given a day of the week. So there are 7 grahas, 7 visible grahas. Visible in the sense you can, for thousands of years, mankind has known about them. So unfortunately, nowadays Jupiter, Saturn. If you go outside and if your sky is clear, you'll be able to see Jupiter on the eastern horizon. Saturn is also high up in the sky right now, and they are very bright and they are visible and brighter than most of the stars. So this has been known to mankind for thousands, even tens of thousands of years, that this is something, a bright star which is moving with respect to the other star. So sun, the moon, and 5 visible planets. Those are Mercury, Venus, Mars, Jupiter, and Saturn. Okay, so these are so bright that they are brighter than most bright stars, and they are have been known to mankind. So based on these 5 visible planets and the sun and the moon, we have 7 grahas on which we name the days of the week. Now comes the conundrum. So in our culture, we have 9 grahas, Navagraha, but these are the 7 visible grahas. So in the last line, you can see Rahu and Ketu. These are the 2 missing grahas, which have a very mythological significance attached, but they have a very solid astronomical concept. So here is how the story goes. So there was a Samudra Manthan going on between Suras and Asura, meaning gods and devils, not devil, demons. So many things came out of it. The story is very long, but then came what do you call nectar, Amrit, after drinking which you cannot die. So there was this demon which drank mischievously drank some poison, but Lord Vishnu cut off his head, and now the body and the head, they since he had drank the nectar, he could not die. So the head and the body, it goes around in the sky chasing the sun and the moon. So after a few months or few years, it manages to catch up to the sun, and then we have a solar eclipse because it is eaten by the Rahu and Ketu. Rahu or Ketu. And similarly with the moon, if it eats up moon, we have a lunar eclipse. So this is a mythological story, how it goes, but basically it is trying to explain this astronomical concept. What happens is you must be aware that phases of the moon gets bigger and smaller because it is orbiting around the Earth, and the part of it illuminated by the sun is also varying. Now if it was in the same plane, the orbit of the Earth and orbit of the moon, then every full moon you would have a solar eclipse, and every full moon you would have a lunar eclipse, and every Amavasya you would have a solar eclipse. But that is not so, because the orbit of the orbital plane of the moon is slightly tilted by around 5 degrees. So that eclipses will only happen when these intersection of orbits will basically align with the full moon or the no moon day. And these intersection points are called Rahu and Ketu. Okay. Excuse me. So this is a very fascinating concept of Rahu and Ketu. So Rahu and Ketu, being the 8th and 9th graha, are actually points in the sky that you can see. There is no physical object present there, but they are virtual, like in Chandrayaan and other orbital mechanics, you would have heard of Lagrangian points. So those are actual points where we launch spacecrafts, but there is nothing present here. So, similarly, the technical name for Rahu and Ketu is lunar ascending and descending node. Okay. So these are the intersection points of orbits where nothing is present, but you can track their position in the sky. And this is how actually eclipses were calculated thousands of years back. So this virtual position of Rahu and Ketu were tracked, and when they got close to the sun or the moon, then you could predict that okay, an eclipse will happen. So that is the story behind Navgrahas. So moving on, there's another mythological story on Dhruv Tara. So many people believe that Dhruv Tara is a very bright star in the night sky. So it's not very bright; it's very mediocre brightness. But yeah, and even in a light polluted place, you can see the star Dhruv Tara. In English, it's called pole star or Polaris. Now, it's not that it's very bright, but its position is so special that it requires this whole mythological story to explain it. So the story goes that there's this Prince Dhruv. He has a brother who is favored by his king father, and he and his stepmother then asked him that if you want to be loved by your father, why don't you go and pray? So then he goes in a forest and worships Lord Vishnu for months and months. Lord Vishnu gets happy and finally grants him a boon that you should be placed in the sky next to the 7 eternal rishis, Sapta rishis, and you will be guiding the mankind, Manota ke margdarshak banoge, and so on. So his boon was to be placed in the sky. Now there is something special about Dhruv Tara. So this is how you spot, first of all, pole star or Dhruv Tara. Either you use the constellation of Cassiopeia or Big Dipper. In Big Dipper is basically Saptarishi and Cassiopeia is Sharmishta in Hindi. So what is so special about it? So here is a star trail. Basically what has happened is I opened or rather aligned the camera towards the north and opened the shutter for half an hour. So this is how the motion of stars happen during that half an hour. You'll see all the stars going around in a circle. And in the center, there is one star. Basically, it's in the center. That is the pole star. So all the stars move around, but there's just one star which stays throughout the night in the same position. Even in the daytime, it's there, but because of sunlight, we won't be able to see. So why is it so? So basically, that pole star or the Dhruv Tara is exactly above the axis of rotation of the Earth. Okay, so this is where the okay, this illustration is basically telling us about the position of the pole star. Okay, so just imagine you are in a room and you start spinning, and what you'll see all the objects in the room moving around because it's you who are rotating, but if you look directly above your head or directly at your feet, you'll see that these 2 points will not move because they are exactly on the axis of rotation. So same thing happens in this image. You can see the farther away the star is or the object is from the center, the faster it moves, and the axis of rotation is clearly visible in such star trails. Okay, then there's this advanced phenomena which I'll just mention. So if you have seen a spinning top, the axis of spinning top keeps on changing from follows this circle. Same thing, this is called a precession of, and it's in this respect, it's called precession of equinox. Okay, so this will cause a shift in the season. So I'll just mention this. Because of this, over thousands of years, the pole star, the Dhruv Tara, will not remain the pole star for us. Okay. So next comes Saptarishi. Next, one of the prominent things in Indian astronomy is the Big Dipper constellation. It looks like a chammach or a dipper. In English, or rather Western constellation, it's called Ursa Major or a big bhalu or bear. But the 7 stars only look like a spoon. So, but in Indian context, the stars have been named after 7 rishis who have their own stories and mythologies associated with them. Special amongst them is Alkor and Mizar. Okay, the English name for them is Alkor and Mizar, and Hindi name is Arundhati and Vashisht. So they are supposed to be the ideal married couple. So in, I think, South India, there is this tradition of after you are married, you are the priest basically tells the bride and the groom to look in the north direction. So what he's telling them is to look at the this couple in the sky, Arundhati and Vashisht. They are very close together. So you have to be behave like them as an ideal married couple and be close. So that is one tradition in marriage that is associated with astronomy. Okay. I'm not able to see any questions. So I just heard there was this question. Are there any questions till now? Okay. Polaris. Okay. Sorry. So if you have any questions, you can just type them. We can take them up later.
I have a
Yes,
question.
sir.
Yeah. What is your question?
Uh, yeah, as we all have heard these mythological stories, and how can we relate these things with the modern science? Because we do not have any identical or data or any valid proof. We are just it is just like sophisticated stories. We are relating to the modern science to get some more response. It just not
Yeah.
look like that.
Yeah. No, so for example, this Rahu Ketu story, basically, Aryabhat and all the rishis, what we call them, many of them actually were studying astronomy only, right? So, when they were calculating eclipses, how would you explain this complicated concept of an object, virtual object moving in the sky, and when it catches up with the sun, it will cause an eclipse? Okay, so to just simplify that, they had to come up with a story, and they came up with this story of immortal demon that goes on eating sun and the moon. So, anyways, it had science behind it, and it's backed up right now also. So, right, even in modern days, if you want to calculate the eclipse, you will actually have to calculate the proximity of the sun and the moon to ascending node or descending node. So, this is one example where you basically have a scientific story woven into a mythology. Similarly, this Dhruv and whatever the story, obviously the whole story doesn't have any significance, but the characters, Lord Vishnu, I think it was Lord Narada who told Prince Dhruva to chant this mantra for Lord Vishnu. So whatever, relating it to religion, and the boon granted to Dhruva was that you will be fixed in the sky or something to that effect. So again, this was to explain that why would you see a star fixed and all other stars rotating. So to explain that, this whole story was created. So for common people, obviously, you would have to explain it in stories, because if you say ascending node or descending node jargon, it won't matter. Anyways, so there is intertwining between scientific concepts and mythological concepts, because people know Lord Vishnu, Vishnu Bhagwan. So you have to include him, and so that's how mythology is born. So basically, whatever cultural concepts or icons are present, you try to explain the concepts linked to that. Anyways, there are many other such things that I'll try to correlate, and you can ask any other doubts and other correlations to science. There are many other wrong correlations as well. So right now there's this trend of assigning any discovery to our ancient rishis. So the problem is not many actually know what the contribution of our ancient scientists was. For example, Aryabhata. Aryabhata was such a prominent mathematician and astronomer in his time. He discovered spherical trigonometry and actually did so advanced mathematical calculations for predicting eclipses and other astronomical things. So the problem is people are not aware of all the details of that, but they are broadly aware. No, okay, we discovered gravity and so on and so forth. So it's a broad brush that we try to apply our knowledge on, but it's the problem is the actual knowledge was very nuanced. I'll try to cover that later on as well. So moving on. So now we come to the interesting part of zodiacs or Rashi. Now, this is where a fine line comes in, because see, right now we are talking of astronomy, but astrology and astronomy are tied in a lot. So there's this theory that goes that, for example, you were an astronomer, a scholar, research scholar, and you wanted sustenance. How would you earn money? For example, you are studying the stars. How would you earn money? Who would give you? Right now, there are businesses like you can show a telescope and earn money from that, or whatever. So right now, there are ways to earn money from astronomy. But in thousands of years back, how would you do that? So the only way, the most prominent way of getting money was get patronage from a king. So basically, a king would sponsor you. But why would he sponsor you? For example, if you are in performing arts, you perform dance or music or whatever, he will give you a prize and give you sustenance. Now, what happened was, I mean, this is a theory, obviously, but it's partially true. So, for example, if you are an astronomer, you could tell your king that this planet is in this constellation, and it's not a right time for you to attack your neighbor. If you want to attack your neighbor, I'll tell you a good time. I'll give you a Shubh Muhurta. So this is how astrology got flourished, because astronomers had to make a living, and the only money that could be given at that time was through the kings. And so this is just one theory, but I'll just give you an idea of how astrology and astronomy are intertwined. So even the Kundli, I'll come to the Kundli part. Kundli is just basically a snapshot of the sky. Right now you use Stellarium and all the software to see the positions of planets in the sky. So that is the calculation of that is also astronomy. But to use that to predict that it somehow has your effect is the pseudo-scientific part, and it's called astrology. So right now I'm only focusing myself to astronomy part, and the astrological part is called Falit Jyotish. Okay, Jyotish is basically the term used for astronomy and astrology. So there are two distinctions here: astronomy, astrology, and the predictive part is called Falit, which we'll not cover. Okay, coming back to this constellations, the modern number of constellations, if you know, are 88. But there are only 12 zodiacs, or 12 constellations, rather rashis that you would be aware of. How is it that there are so many 88 constellations and only 12 of them are relevant? So, for example, Saptarishi, that is not a zodiac, but still, and other would be Kalpurush that you are aware of. But other than that, in Indian astronomy, you would not see many constellations which are not zodiacs. So why is what is special about zodiacs? So this diagram would illustrate a lot. So imagine you are sitting on the Earth here, and what is something peculiar that you see? You see that all the orbits of the planets are more or less in the same plane. So if from Earth you are looking at any other planet, you will see you'll see them in a single band. Okay. Now, what does this mean? The band in the sky in which all the planets are present, even the moon and the sun also are in the same band. So that band is called the ecliptic. The ecliptic is basically the path the sun takes in the sky. So because of the planar nature of the solar system, what we have is that Jupiter, Saturn, and all the planets are only visible in this narrow band in the sky. And that narrow band is basically called the zodiac belt. Okay. So this is basically in the bottom you see the whole night sky projected in a planar format, and on the top you see, because of basically it's showing the 12 zodiacs, and as the Earth goes around the sun, you'll see that the sun is seen in the different zodiac constellation. So it's not that you can see the sun in the constellation, but for example, just after the sunset, you'll see one zodiac constellation, and just before the sunrise, you'll see you would have seen all the other 11 constellations. So the one which was not visible in the daytime because the sun is in it is the zodiac the sun is in. Okay, so basically because of planar nature of the sun, this 12 constellations are special. Okay, there is also one special thing. I told you initially that there are 12 months. Okay, so it's not a coincidence that there are 12 rashis. You could have made, first of all, constellations or zodiacs are all man-made imaginations. Okay, so it's not like there is an actual Scorpio in the sky. If you see the Scorpio constellation, it does resemble it, but you could have made more constellations on the zodiac. Why only 12? So just to make 12 months, because of 12 lunations or 12 full moons, we have defined 12 rashis. That's why 12 months are there and 12 rashis. It's the same reason to have them both. Okay, so this is the division of zodiac belt in 12 equal parts. That's why we have 12 months. Now there is something special. You could divide this zodiac belt. Okay, so this is basically another image showing the same. 360 degrees divided by 12, 30 degrees each. So this belt, if you take 30-degree part of it, you'll get each zodiac. Now, if you divide it in, again, another concept, Sankranti. So, there are 12 months. So there are 12 Sankrantis. So basically, as seen from Earth, the sun moves from one zodiac to another. So a movement of the sun from one zodiac to another is called a Sankranti. You are not aware of the other Sankrantis. The most prominent one you would be aware of is Makar Sankranti, right? Makar means Capricorn. So that is the one generally people are aware of. But every month there is a Sankranti. That's why we have months. Okay, so this is basically the movement of sun in the sky from one constellation to another. So one misconception I'd like to clear: Makar Sankranti is not the start of Uttarayan. Okay, so Uttarayan is when the sun starts to move in north direction, and this used to be the same. So this basically relates to the concept of precession of equinox that I mentioned previously. So 21st of December or 22nd of December is the start of Uttarayan, the shortest day. After that, the day length starts to increase. So this is when the day length starts to increase and the sun starts to move in the north direction or Uttar direction. That's why it's called Uttarayan. The sun is now going in Uttar Disha. So Makar Sankranti used to be the same date. The day when the sun entered Makar Rashi used to be the start of Uttarayan. This was 1500 years, around 1500 years ago. But because of precession of equinox, that date has now shifted to 14th of January. And if you wait for hundreds of more years, it will shift to 16, 17, 18, and it will keep on shifting because of precession. But people still call it as the start of Uttarayan, which is not true. You can observe the movement of the sun, and that starts on 22nd. So there is this concept of Nirayan and Sayan Rashis in our traditional astronomy. I'll not get into deep of that, but basically the Uttarayan is determined by the Sayan Rashis, and the Rashis that you see actually in the sky that are called Nirayan Rashis, and that Makar Sankranti happens on 14th of January right now. Okay, now we saw the division of zodiac belt or the Rashi Chakra in 12 parts. The same 360 degrees can be divided up into 27 different nakshatras. So this is one of the panchangas. Okay, panchang basically is our lunar calendar, right? So actually it's lunisolar calendar. So what we have is 5 different things that tell us the time. One is the tithi. Tithi is I'll cover that in a future slide. Tithi tells the phase of the moon. Then there is paksha and var and all that. Nakshatra is one of that. So there are 27 nakshatras. Nakshatra is basically just a you saw these, for example, this belt, right? Right now you see 12 constellations written on the top diagram. The same can be clubbed into 27 different stars, and that are called nakshatras, and the names of them are given here: Ashwini, Bharani, Kritika. You might be familiar with some of the names. For example, Pushya. Pushya nakshatra is basically in Cancer and is considered to be good for purchasing gold. Then there is Chitra, Swati. Many of them are familiar girl names in India, right? Revati, Kritika, Rohini. Kritika is like M45 or Pleats. So these basically are stars. So why do we need 27 nakshatras, right? So one way of keeping time is seeing the shape of the moon. That will tell you whether it's full moon, half moon, or that division in 30 tithis, 2 paksha and 15 tithis is one way of looking at it. The other is in the night time you look at the moon and see which is the star next to it. Okay. So for example, it is next to Kritika or the Pleiades constellation. It will take 27 days for the moon to complete one cycle around the sky and come to the same star. Okay, 29 days to complete a cycle of the phases of the moon, and 27 days to complete a cycle with respect to star. This is called a sidereal motion, and the other one is called synodic motion. The difference of 2 days is because the Earth has moved a little bit in that time, in this 1 month. Okay, so the best way to keep track of time is you just mark 27 stars around the ecliptic, and one day the moon will be present in one of the nakshatras. So that is a simple way to tell the position of the moon in the sky. That today is Kritika nakshatra. That means if you look in the night sky, you will see the moon present in next to that nakshatra. Okay, now comes the naming of the months. Okay, so these are the 27 names of the nakshatra. You can see them in the night sky, these 27 stars or group of stars. Now, what you see here are the names of 12 months in Indian calendar, like Chaitra, Vaishak, Jyeshtha, Ashad, Shravan, Bhadrapad. You will see that these have some resemblance to the names of the 27 nakshatra. So what basically happens is, see this, the first month of our Indian calendar is Chaitra. Chaitra means from Chitra. Chitra is this nakshatra. Chitra is basically, I think, Spica in Virgo constellation. Okay, so this when you see a full moon next to Chitra, you will have Chaitra month. Okay, and then Vaishak is 2 or 3. So basically, after Chaitra, it's Vishakha. Vishakha nakshatra that corresponds to Vaishak month. Jyeshtha is this one here, if you can see the cursor. Then we have Shravan, Bhadrapad, Ashwin, Margshirsh, and so on. Paush is Pushya nakshatra that I talked about in Cancer. That is Paush. So why we have chosen like 27 divided by 12, 2.5 something, whatever the division value is. So after every 2 and some decimal of nakshatra, we'll have 1 month. Why is it named so? So what happens in month of March is that you will have spring, you will have a full moon, and if you see the full moon in March, it will always be next to this Chaitra or rather Chitra nakshatra. So why is it always the same? Just look at this image in the right. For example, here the sun is present in January and December, right? So when in this image you will only see the sun and the earth plotted. The sun is visible here, and if it is a full moon, you can imagine that it is diametrically opposite to the sun. So it is somewhere here where July and June, Gemini and Taurus are there. So basically what happens is that the full moon you will see in this time when the sun is seen in Sagittarius Scorpius, the full moon will be between Gemini and Taurus. Okay, so based on the month, you will always have the fixed position of the full moon in that, and the full moon, wherever the full moon is seen, in whichever nakshatra is seen, we mark the name of the month based on that. So all these names of the months are based on the position of the or the names of the nakshatra where that full moon was present in. Okay, so that is how the month names have been formed. So there's one more division. So right now we divided this Rashi Chakra in 12 parts. In 12 parts we saw the Rashis. In 27 divisions we saw the nakshatras. There's one more division which is called the Charan or Pad. Okay, you would have seen in Hindi newspapers this strange terms like Lile, Lu, Keko, Ka, Chechu, or some single syllable words. So what are these? So basically what happens is that you divided the 360 degrees into 27 parts. Now you could divide the 27 nakshatras, each of the nakshatra, into 4 parts. So as I said, that moon will spend 1 day in one nakshatra, right? So yeah, for example, today is in Kritika nakshatra. So we have 24 hours in a day approximately. It will more or less be the same. Although it does vary the nakshatra duration. But for example, around if you have divide the nakshatra in 4 equal parts, the moon will spend around 6 hours in one of the section or one of the charan. So in this image, if you see Kritika is third one, E U A. It is written E U A. So they are named E U A. So for example, in the first 6 hours of the day, the moon was in the charan, then E, then U, then A. So it's another subdivision of nakshatra. But what does it imply in our cultural life? So when you see the kundli of a child, the moon, the position of the moon in the Rashi Chakra, that either you give the Rashi of the moon, that is also obviously given, but if you give the precise location, you'll see that it is in one of these charan, and that is basically how the birth name of a child is determined. So for example, it is in Rohini and first charan, so O, Va, Vi, Vu. If it is in first charan, the child's name should be from starting with O. So that is what charan implies. So it's just a subdivision of the ecliptic in the night sky. So moving on, now we come to the kundli, right? As I was saying, kundli and making of kundli is basically all astronomy. The pseudoscientific parts come when you assume that planets have some bearing on our life and it affects the life of humans somehow. Okay, but just making the kundli is all astronomy. What basically kundli is a star chart. So here is a kundli, right? You can see the it looks very complicated, but just see that there are 12 rashis in white color. You'll see 6 Virgo, 5 Leo, 4 Cancer, 1 Aries. So Aries, that is Mesh Rashi, is here. So it is basically telling you the 12 zodiac constellation. It is in a cyclic order. So just imagine a circle of the 12 rashis instead of this. It's just easy to draw. That's why there are different formats. For example, this is used in North India. In South India, there is this small squares placed around differently. So and in East India, there is another format. But all of them basically are trying to place the planets in their respective zodiac as seen from Earth. Now you'll see. Basically, it's a snapshot of the sky. Right now, if a boy or a girl is born, you just see the stars and you see all the zodiacs and the planets. So it is just taking a photo of which planet is in which zodiac constellation and so on. So it's basically a snapshot. Now another interesting concept comes, which is Lagna Rashi, and it's in English it's called ascendant. It's also very important. For example, okay, so I'll just give you one interesting thing, how you can use a Kundli as actual sky map. So just take your Kundli, if you have it on phone, just hold it in your hand, and there is something called Lagna. Okay, wherever this Lagna is written, align it to east direction. Okay, so for that you'll have to rotate this Kundli by 90 degrees and maybe face south. So when you're facing south and aligning it with Lagna Rashi with east direction, basically you will see the bottom half of the bottom 6 constellations, zodiac constellations, have been are below the horizon, that is below the Earth, and the other 6 are on top of them. And it actually tells you Lagna is east. So from that, for example, in this image that I'm sharing, Virgo can be seen on eastern horizon. Above that is Leo, and above that is Cancer. Gemini, that is Mithun Rashi, is overhead, then Taurus and Aries, and on the western horizon you can see Pisces, that is Meen Rashi. So it actually tells you which constellation is where and the position of planets as well. So that is how you can actually use a Kundli to see the. But yeah, that Kundli is for that time of birth. If you're looking at your Kundli, what you're looking at how the sky was at your time of birth. Okay. For right now, if you want to see the star chart, you just have to get the Kundli of a newborn. So the current sky is basically what the newborn's Kundli will be. So this is just another way to depict the same, and you can see the relative position of the moon with respect to the sun in the Rashi Chakra tells the Shukla Paksha and Krishna Paksha. I'll try to cover that in a future slide. Okay, so any questions till now? I'll be changing gears and moving to a daytime astronomy now. So any questions till now?
No, sir.
Okay, so I'll now cover daytime astronomy. So till now we have been looking at grahas or planets, right? And moon is also a planet. So I'll also cover that separately. So now comes daytime astronomy. Okay, so we saw the planets and their positions and all tracked on. I didn't go into detail of how Aryabhat and others could have tracked the positions of the planets and calculated all that. But now comes the basic question. It is daytime. How could you utilize the sun to find the time of the day, right? It is sunrise. It's very easy. Okay, sun is rising. It's morning now, right? So the most basic thing to do is see if there is sun in the sky, that is it's daytime. That means the sun is above the horizon. If it is below the horizon, it's nighttime. Okay, that's the basic division. But in the daytime, you can actually use the position of the sun in the sky to find the exact time. Okay, so the demonstration here is Jantar Mantar. Although Jantar Mantar is a very modern instrument, it's like 300 years old only. But it was well known to use the sun's shadow, or rather any object shadow, to know the time. So it's basically a sundial. Sundial is basically how you tell time using the shadow made by the sun. So Jantar Mantar, the image that you see here is the biggest sundial in the world. This is a Samrat Yantra in Jaipur. It is so big that you could tell time with the accuracy of around 2 seconds. Okay, First of all, it tells local time. I won't go in deep into that. So there is something called standard time that we follow the Allahabad meridian, and then there is local time, and there is a lot of complicated time. But it will tell you the local time with a lot of accuracy. The bigger sundial you make, the more accurate you'll get the time. So how does it tell the time? Now basically the sun will rise near east. It will go higher and higher. Then it is basically it will be at its highest at what we call local noon, and then it will come down, and we will have the height of the sun coming down, and then it will set. Now this whole daytime can be divided into two parts. Okay, so this is illustrated here, although it also explains Uttara and Dakshina. I'll just consider one day. So see this image, and you'll see that sunrise to the image of the sun, you'll see the sun is getting higher and higher. And basically the north-south line is called meridian. Okay, in the sky, if you join the north direction and traverse the sky to south, this line is called meridian. So this is the point where the sun is at its highest. And when it crosses this meridian, it's called noon. Now, when the sun is before the meridian, it's called ante-meridian, and not ANTI meridian, but ANTE meridian. I think it's Latin for before. So when the sun is before the meridian, you have AM, okay, ante-meridian. And when it has crossed the meridian, we have PM. PM is post-meridian. Post is obvious, so after meridian. So when the sun is before meridian, we have AM, and when it's after crosses the meridian, it's PM. So that is how the division of day AM, PM comes around. Okay. Now in this image, you also see the movement of the sun throughout the year. What happens is that the Uttarayan and Dakshinan motion of the sun, first of all, this is all because of the tilt of the earth. If the orbit of Earth, axis of Earth wasn't tilted, you would not see the variation of daytime and nighttime. But since it's tilted and it is going around the sun, the path of the sun in the sky changes, and the day duration, night duration also keeps on changing. As you see here, you'll see that as the sun goes higher and higher, you'll have summertime because you get more heat for that location, and when the days are shorter, you get winter. Okay, so this motion is called Uttarayan and Dakshinan motion, and so this image illustrates it better. Okay, so there is one more interesting phenomena called zero shadow day. I'll not go into detail of it, but there is only a few places between Tropic of Cancer and Tropic of Cancer. Every place in between Tropic of Cancer and Capricorn will have 2 days when the sun will go overhead. You can easily see in this diagram. For example, this image is for a location which is obviously above the Tropic of Cancer. So the sun will never pass overhead. So zero shadow day is a day on which the sun will pass directly overhead. This will only be for an instant, okay, and not to confuse with a cloudy day. Obviously, you won't have a shadow when it's a cloudy day. The phenomena we are talking about is when the sun is overhead, it is shining, and vertical plane objects like a pole or a cylinder will have zero shadow. So this will only happen twice, and it's a special day because on that day that location is basically the nearest to the sun. So just to mention that is also something that is that we observe in tropical regions. Okay, so So in this image, you can see there are different parts of the sun. Like in this image, here you can see a different perspective. You are looking at the sky from outside of the universe. But you can see the rising point of the sun keeps on changing. Okay, so I'll just address this one point. It's a misconception that the sun rises exactly in the east and sets exactly in the west. Okay, it's right to say that it rises towards the east and sets towards the west, but exact east and west, rising and setting, that only happens on 2 days. As you can see in this image, that only happens on equinox when we have equal day and night. So only on equinox the sun will rise exactly in the east and exactly in the west, sets exactly in the west. How you can observe? You can also observe yourself. So this is a time lapse that I have taken on the day of 18th December. You can see this is west. So basically this is sunset that I captured. You can see the path of the sun while it's setting. It took on 18th of December. Okay, and after 1 month, 18th of January, you could see the path had shifted towards north. Okay, right hand side is north, and we are looking towards west. And still, this is not exact west. So if I zoom out a bit in this image and see and capture this for equinox, you'll see that this will keep on shifting north till 21st of June. Okay, that is what Uttarayan means. So you can also do this activity. Just observe the rising or setting point of the sun, and you'll see that this day-to-day change. Even one day might not be sufficient to notice the change, but you can do this week after week or even month, and you'll see the path of the sun changing. So daytime, in the daytime, never look at the sun directly. Shadows is one way to track it, but better than that, you can just capture a sunset and see the from the same spot. Just keep sure that you are viewing from the same spot. If you keep on moving, obviously the angles will change, and because of parallax you might change. If you use the same point of view, you will see the sunset point changing. Okay, so this can be captured in Shankhu Yantra. Okay, I just told you can observe the setting point of the sun to track this. There is one more way to track the motion of the sun in the daytime sky. That is the Shankhu Yantra. Shankhu just means a gnomon or just a simple pole. So this yantra, this is a yantra in Jantar Mantar, but the image that you see is a custom one we have made. So a Shankhu yantra would be different for all latitudes, so you'll have to make one for yourself. So a simple way to do that is just mark a pole, and on the day of equinox and on the day of summer solstice, winter solstice, just line the just mark the tip of the shadow made by the fixed object. First of all, the object has to be fixed along north-south line, and do not move it. Even if you move it, just make sure that it's aligned properly. Or you can, for example, if you're on a roof and there is a pole or something, you can just mark the tip of the shadow on these special days or any other day. You will see that on different months, the path taken by the tip is different. So what this yantra has is different lines for different months. So it will actually tell you the day of the year as well. If you know it, whether it's Uttarayan or Dakshinayana, or if it's on the blue line, it will be winter solstice. If it's on the red line, it's the longest day of the year, summer solstice. And correspondingly different months can also be known. If you make it big enough and mark even smaller lines, you will actually know the day of the year as well. Okay, so Shankhu Yantra tells you the time of the year, as in the day of the year, and sundial tells you the time of the day. So that way the sun will tell you both the times. So this is how time keeping has been done with respect to the sun. Okay, so in archaeoastronomy, you'll see this is basically an image of Stonehenge. You would have heard of it. Stonehenge, and even now you would have seen some viral images of temples and all. So in earlier times, all the construction that was made was used by making the north, south, and east, west alignments. And how, if suppose you are a 5,000 years back or 10,000 years back, you are a farmer. How would you keep track of the time, right? You wouldn't have printed calendars or anything. Obviously, season you could keep track. For example, it's winter, it's cold. That's one way to keep track of it. But if you want precise location, for example, you are in a farm and there is a faraway landscape. You just notice the rising location of the sun, right? You see that it is going in a cycle, like in the image I shown here. It keeps on changing. So, for example, if this is from my roof, I could say that it's winter when the sun is rising near this multi-story building, and when it is rising near this cell phone tower, it's January or February will be about to start. So same way, Stonehenge and other structures have been made for thousands of years. Stones have been placed from one viewpoint to mark the different rising or setting points of the sun to tell you the time of the day. So this is basically archaeoastronomy, and many temples, and even before that in Harappan culture, and even before that, the Stonehenge is like 5,000 years old. So the structures that have been placed have been generally placed to mark the rising and setting points of the sun, which basically told the time of the year to the humans. So this is one important aspect of how astronomy also was used to keep track of time. Okay. So, I mentioned Lagna Rashi, although it's slightly different from that. Lagna means, although Lagna means marriage in common language, but Lagna, marriage means joining of two people, right? So, Lagna Rashi is basically, I told you that there is this Rashi Chakra going on in the sky. Okay, that is Rashi Chakra. Then there is something called horizon or Kshitij, right? Where the sky meets the land. So, but there are 2 points where this Rashi Chakra meets the this horizon, right? The rising in east direction, this is called Lagna Rashi or ascendant. Okay, so I'll just mention this. So this is what Lagna Rashi means in astronomy. Okay, and it's heavily used in astrology because it's basically tells you which zodiac is present where. If you know the Lagna Rashi, you know all the other positions of all the other zodiacs. So this is one more concept that I mentioned. So okay, so now I'll briefly mention Panchang. I have already mentioned many of the concepts of Panchang. So this is a screenshot from one of my apps, Hindu calendar. So what is basically different in Hindu calendar, or rather the Panchang that we follow for festivals? Okay, so in Gregorian calendar, 12 o'clock start. In the midnight, we have a start of the day. The day changes there. But in Hindu calendar, the day starts from sunrise. So a day only changes when sun rises. In the night time, it's the same, considered the same day as right. For example, right now it's around 8 o'clock. Till 6 o'clock or 7 o'clock in the morning, it will be considered the same day. And when the sun rises, the new day will start. And the at the time of that sunrise, whatever the tithi is prevalent, that will be marked for the whole day. So I'll not get into the details of that. So, for example, as you see, the rising, setting time of sun, moon, and every object is different for different places. So that's why Panchang for every place is different. That's why it's very complicated. In previous time, Ujjain was considered the standard meridian, like we have GMT right now, Greenwich Mean Time. But for Panchang calculation, Ujjain was considered the standard meridian in previous time. So I'll just quickly go through all the other slides. So there are different coordinate systems. It's slightly technical, but the one used in Panchang calculation is ecliptic coordinates. So Rashi Chakra is the one we are concerned with. In modern astronomy, what we use right now, what is called equatorial coordinate system, based on the Polaris and all. So I'll also skip that. So one interesting thing that you all can do. Okay, I told you about the sun. I'll talk about the moon. So looking at the moon in the sky, you can find out a lot of things. Okay, so first of all, Tithi is basically the angular distance of the moon from the sun. Okay, when there is Purnima, why is it? First of all, why there is Purnima? Because the moon is opposite to the sun in the sky. That's why it is fully lit, right? So that means the angular separation of moon and the sun is 180 degree. Okay, along the Rashi Chakra. So every 12 degrees there is a change of a tithi. So 180 degrees on this side is Shukla Paksh and Krishna Paksh. I'll just show this image. So what you see here is, first of all, when you look at the moon, you see a part which is illuminated and part which is not illuminated. So obviously the part which is illuminated is the one pointing towards the sun. So for example, you see a moon in the sky, and it will tell you the direction of the sun. Obviously, if it's nighttime, the sun is below the horizon, it's below you. But you can actually see, follow the this arrow, basically where the illumination is, and see the sun. That's not all. The further away, the bigger the moon is, the further away angle you have to go. So, for example, if it's no moon, obviously it will be next to the sun. If it is half moon, the sun will be 90 degrees away from the moon. The sun will be 90 degrees away from the moon. If it is full moon, the sun will be 180 degrees away. So I'll try to illustrate this from this beautiful song in Hindi. Aadha hai Chandrama, Raat Aadhi. So this is a very old black and white song. Aadha hai Chandrama, Raat Aadhi, rehna jaye teri meri baat aadhi. So with this line only, you can actually pinpoint the position of the moon in the sky. How? Because he says Raat Aadhi. We can assume it's around 12 o'clock in the night. Aadha hai Chandrama, that means the moon is half lit. And what does that mean? The sun is 90 degrees away from the moon, and since it's 12 o'clock, it's right below you. That means the moon is either about to set or is rising. That's why it's a very poetic song, and he's describing this moonrise or moonset, depending on which paksha is there. Okay, just to illustrate this more clearer, this is a viral image that has been going on forwarding for many years. I've seen this for many years. Obviously, it's a fake, but the caption was something like the photographer kept the camera for 62 days to capture this alignment. So now you would know that this image is not possible. Why so? Because you see the sun and the full moon in the same frame. So you know that Purnima, the sun is opposite to the moon in the sky. So in a Purnima, you'll observe that when the sun is setting, the moon is rising, and vice versa. The sun will set and moon will rise. So the sun and the full moon will be 180 degrees opposite in the sky. Okay, so this is a basic textbook image explaining the phases of the moon and how is this go, how the pakshas and wake waxing and waning phase go. So nakshatra, yoga, karna, all this I have covered. So I think there are many other things, concepts that could have been covered, but they are all related to calendar. So I'll just skip them and we can straight away move to question answer. I think it's 8 o'clock right now. So thank you. I'll take questions now. Yeah. Yeah. So you can unmute and ask your question. Okay, sure.
Sir, I have a doubt. So, like,
Yeah.
as you said that in the first, like, Navagraha, and
Yeah.
you said that 9 planets, but how did they discover the 9 planets? Like,
So,
how did
okay.
they know?
No, so okay. See, the problem with us right now, we have totally detached from the nature, totally detached from the night sky. I, being an astronomy professional, I generally show students and general public telescopes and planets and all. But general public does not know that you can actually even right now see the planets with your own eyes. 5 of the planets: Mercury, Venus, Mars, Saturn, and Jupiter. Only these 5. Uranus and Neptune obviously cannot be seen with the naked eye. So if you go right now outside and it's clear, you will see there is a bright star on the eastern side. Right now it's 8 p.m. So depending on your location, it might be higher or lower. But if it is clear, the sky is clear, you will see a bright star towards the east. That is Jupiter. It's one of the brightest objects right now in the night sky. In fact, the brightest object in the sky right now. Okay, now Saturn, that is also very bright. Similarly, Mars. So, for as I was initially saying, for thousands of years, even tens of thousands of years, mankind was aware of bright objects moving around in the night sky, moving around with respect to other stars. Okay, they could see the stars, constellations, and all, but with respect to these constellations, a planet basically means a wanderer. Planet is a wanderer in Latin, or I think Greek. I think Latin only. So it keeps on wandering around. Okay, so 5 of them: Mercury, Venus, Jupiter, Saturn, and Mars. So they are wandering around this kind. We have mankind has known them for tens of thousands. Only now, because of urban life, we don't see the night sky. But even in light polluted sky, you can see these 5 with your own eyes, without any binocular or without any telescope. Right? The other 2, sun and the moon. So the definition of grahas is different from planets. That's why 7 days of the week I mentioned. Now the technical part is Rahu and Ketu. So that is where the scientific part or the research part of rishis came in. Yeah, I saw the comment. Mercury is usually hard to see because it is very close to the sun. So you'll have to wait for the right time for it to. Even then, you'll have to see it at the sunset or just before the sunrise. So yeah, Mercury is hard, but still visible to the naked eyes. Now, other than these 7 grahas, the 2 other Rahu and Ketu basically were found because eclipses were like very interesting phenomena, right? For thousands of years, mankind would have tried to study what time does solar eclipse or lunar eclipse occur. So they found a pattern that there is this virtual point that is moving around in the sky. Actually, that motion is, I think, 19 years cycle is there with respect to the stars. They just found that data pattern that there is this virtual point in the sky wherever the sun and the moon gets close to it. There is an eclipse. So those 2 virtual points, actually, there is nothing to see in the sky, but still, because of applying mathematics, they could figure out that there's this point where whenever the sun or the moon comes close to it on Purnima or Amavasya, you will get an eclipse. So that's how they discovered Rahu and Ketu, and they had calculations to track the motion of all the grahas, including Rahu and Ketu. So that is the story of Navagrahas. That's why they were made deity and introduced, or rather tied into our culture and religion. So that is the actual story of how science at that time now was combined in our culture. Okay. Yeah. Next question.
Sir, sir, I have one more question.
Yeah.
Sir, like example, like there is Arabian astronomy, like
Yeah.
Indian astronomy.
Yeah.
So like these are all like perspectives of the like
Yeah,
people,
yeah, yeah.
right?
So
These are
even yeah, so even Indian astronomy has been borrowed from Babylonian. So the thing is, even the Rashi Chakra and all that I'm mentioning is not mentioned in the Vedas. Okay, Rig Veda, Yajurveda, and all. If you see, the only mention of nakshatra is there. Okay, so in China also, you'll see that they have lunar mansions. What we call nakshatra, they call lunar mansion. They are 27. So they also kept track of time using those. So in early Vedic period, there was no mention of Rashi Chakra anywhere. So that was, you can say, invented by Babylonians 800 BC, 700 BC, or whatever. That was being, that knowledge transferred to Greeks, Latin, Roman Empire, and to India also. And we also adopted even the 7 days of the week. That was a invention or coined by the what you call the Babylonians and adopted elsewhere. So that way, the Indian knowledge also, for example, Aryabhat contributed a lot to spherical trigonometry and, in fact, trigonometry. So trigonometry was born in India, then that was passed on to Islamic scholars, and Islamic scholars then passed it on to Renaissance scientists, and then finally we know at sine cos. Basically, that was Jaya and Kotija. That was all in Indian mathematics. So that is how knowledge transfer happened. Babylon, Greek, Indian, Islamic, then Dark Ages were there in Europe. Then finally Newton and Leibniz and all those mathematicians, they finally discovered all that. So yeah, Islamic, as you said, and yeah, just basic concept of constellation. So even if you go right now in the night sky and see a pattern, so that pattern will you can make your own. For example, if everyone can make their own pattern by looking at a cloud, similarly constellations, everyone can imagine their own story and folklore associated with. That's why different cultures had different names for different constellations, but zodiacs generally have been the same because that were associated with the ecliptic. And if you'll see in most cultures, the zodiac constellations are the same name. Okay, because the knowledge transfer for the zodiacs, other than zodiacs, you'll see the names of the constellations and the shapes and stories totally different for different cultures. Yeah, Kashyap, you can
Thank you,
ask.
sir. Thank you, sir.
Hello. Yeah, Kashyap, you have raised your hand. You can ask your question. Okay, I'll see some questions in the chat. If everything are given in astrology about space science, then why humans are investing? So, see, astrology does not give anything about space science. Even the science that I'm talking about in Indian astronomy, it's all positional astronomy. Okay, so you see the distinction between modern astronomy and traditional astronomy. Even in old West astronomy, if you see, we are only concerned with the positions of the planet in the sky and seasons and all timekeeping. So it's all very important. But we never talked about the composition of the sun. So what goes on in the sun? Okay. So for that, you would need the concept of hydrogen fusion, that fusion of hydrogen to helium, and how the sun generates its energy and all. So that is not being discussed uh, or studied in Indian astronomy or even in any other astronomy. That was only possible because we discovered invented the telescope, we invented spectroscopy, we could study the elements present in the stars, the faraway stars as well. Then came study of light and all the other phenomena, interference, diffraction, and all. So after the advancement of science and invention of new instruments, we could study the composition of stars, galaxies. Now we could even talk about dark matter and all. So the traditional astronomy is not concerned with all of that. It's only concerned with the positions of stars, planets, the season, and all this. So that is a disconnect between modern. So if you attend any other modern astronomy talk, you'll always hear about black holes, galaxies, formation of stars. So that is a big disconnect. So that is not what is covered in traditional astronomy at all. Okay. So yeah, I see. Does the planet position really impact human? Like we talk about Graha Nakshatra. So I don't personally believe in any of that. So as I said, the scientific part, I only covered the scientific part of that astronomy. So even in our Indian astronomy, you'll see all this intertwined. I only mentioned the astronomical part. For example, I mentioned Pushya Nakshatra. Even now, whenever there is Guru Pushya Yog, that means on Guruvar, when the moon is in Pushya Nakshatra, it is considered auspicious to buy gold, right? But it's all pseudo-scientific. It's not the scientific aspect of moon being in Pushya, and there is nothing scientific about believing that it will affect your future somehow. So that is where your belief, or rather the pseudo-scientific belief of astrology comes in. So Gurpreet, I answered your second question also, that planet's position affects one life. So scientifically, there is no reason to believe that. So if it was the case, I'll give you some points to ponder. If really one could use the planets to predict future, then we could have avoided many calamities, and the one who could actually predict the stock market would have been a billionaire by now, because he could use the planetary position to time all that. But anyways, all these are matter of belief, because many people in stock markets also still believe and use the muhurtas. For example, many of my users, so I have this app called Hindu Calendar on Android. It's one of the most famous Panchang apps. So I get the query of purchasing cars and houses and whatever. So I never consult the muhurta to buy anything, even though I made the apps and it has the calculation of many of the muhurtas. But many people use that app to purchase. So it's their belief, and obviously not based on science. So thoughts on Surya Siddhanta. Surya Siddhanta is basically an astronomical treatise. So I told you Aryabhat and other scientists at that time, basically they had methods of plotting or rather finding the positions of the planets in the sky. So how did they do that? Simple interpolation. So you see the path of the, for example, you would have seen data regression, right? So for example, if you have x and y axis, you plot x, y, 1, 1, 1, 2, 2, 3, 3. So you see that the data is following a straight line. But if it is 1, 1, 1, 4, 2, 4, 3, 9, you see it's following a parabola. So basically, you plot the points and see which curve is fitting, right? So this is data interpolation. So what they did was they saw the positions of the planet in the night sky and saw that the planets are dancing around. They saw the retrograde motion also, that Mangal Graha is going ahead and then going back. So they just fit a curve in between them and tabulated the predictions, right? For example, we have seen for hundreds years the path of the planet. It's this trend they are following. Now for next 200 years, we give you a table, a formula, which will tell you. So very crudely, that is what Surya Siddhanta is, right? So it's a model, astronomical, mathematical model to predict the positions of planets. Again, it's all astronomy. So this was a question of Kamal Raj. The next question is, Sun is moving in space-time around our galaxy or other smaller bodies in solar system like Vesta, Ceres, etc. I don't think astrology even mentioned those. Yeah, so Vesta, Ceres and all, they were not even known to mankind, even till 1600. So the telescope was discovered by Hans Lippershey, and the first astronomical usage of that was done by Galileo. So before Galileo, obviously, we did not know about the moons of Jupiter. We did not know about the dwarf planets. Uranus, Neptune, Pluto were not discovered. So for that, we had to wait for big telescopes, right? So basically, we were not, even as I told you, there were no there was no spectrography or study of elements or composition and all. So no astronomy, even Islamic or otherwise, or Western European astronomy was not considered with all this modern astronomy, dwarf planets, solar system formation. So it was all to study the celestial sphere. They saw Jyotir Vigyan. So basically, they studied the lights in the night sky and the data in the sun, and just studied the position and the movement of all that. So you can call that positional astronomy. So that is all the traditional astronomy has been associated with. And all the concepts that you mentioned, Vesta, Ceres and all, obviously came after telescopes invention. Yeah, next question. Leap year concept. Yeah, so this is a very interesting concept, leap year and supermoon. So supermoon, I'll explain the supermoon first. There are many fancy words being used in media right now. So basically what is, if you imagine the orbit of the moon around the earth, if it was perfectly circular, you would see the moon the same size all the time, right? It will change its phase, but the radius or diameter of the moon would remain the same, even if it is invisible or half visible or whatever. But since the orbit of moon is slightly elliptical, so it sometimes comes close to it, sometimes it's far away from us. The variation is very small. I think 5 or 11% difference is there. So what happens is when the moon is closest to us, and at that time there is a full moon, we call that as super moon, right? Super moon, and there is micro moon when it's the furthest away from us, and we have a full moon. So it's only on full moon that we'll observe. Otherwise, if it's very small and it's nearest to us, you won't observe because it would only a small portion of it will be visible. So that is super moon. That happens because the moon's orbit around the Earth is elliptical and its distance is varying. Now leap year. That's a very interesting thing. So leap years are in Gregorian as well as or Hindu calendar. Gregorian calendar, there is something called blue moon, right? So blue moon is very mistaken or wrong term used by common public. So it's blue moon. It's called blue moon, but it's not that the moon will be blue. Whenever in a calendar month there are 2 full moons, we call that as blue moon, and that happens rarely in 2 and 3 years. And that's why we call something that happens rarely that once in a blue moon this will happen. Okay, so once in a blue moon means it happens very rarely, and that means in one calendar month we have 2 full moons. Now the same thing when when the sun is present in one zodiac and 2 full moons are present, we in our Indian calendar or Hindu calendar Panchang, we call it as Adhik Mas. See, there are 355 days if you consider 12 lunar months, right? 29 days for each month and 29 point something, whatever value decimal is there. So after 355 days, you will have the start of the 13th lunar month. But as you see this with the seasons, there are 365.25 days in a solar year. That is for the same Earth to come to the same point, you will have to wait for 365.24 something days. Now there is a difference of 10 days or something, right? So if we don't have a correcting mechanism, what will happen is that the festival will keep on drifting. Right now, Diwali is in November, right? It will shift from October. So this happens in Islamic calendar. If you see the Hijri calendar or the one followed in Islam, it's a pure lunar calendar. What they do is they only see the phase of the moon, Purnima Amavasya, whatever they call it. Now they have Ramzan, the month of Ramzan. You'll see that over the year, the celebration of Ramzan keeps on changing. So this is because they don't correct for this 355, 365 days. In Indian Hindu calendar, it's basically a lunisolar calendar because of this Adhik Mas, which is a leap month added to our calendar after every 3.5 years, and that is also determined automatically. No one adds it manually. The Adhik Mas is when the sun is in one zodiac and we have 2 full moons. So automatically it is taken care of, and every 3.5 years we have a Adhik Mas, and the festivals are always in sync. Okay, so yeah, next question is why is the Hindu calendar little off than actual observational one? Yeah, so calendar is not off. What is off is the nakshatra. Yeah, and the reason you have pointed out is correct. Axial precision. So that whenever there is this nakshatra mentioned for today, and you see the moon is slightly off, that difference value is called Ayanansha. So that has accumulated in 1500 years. So that visual difference is there. But again, there are 2 different ways of looking at Sign and Nirana. It's slightly technical, but yeah, that discrepancy, whatever is in visual observation, that discrepancy is because of precession. The another question asked is all the Jantar Mantar Venus Bapu solar observatory. Okay, so again to highlight the difference between older observatories and modern observatory. Older observatories had instruments to track the shadow, use somehow the position of the stars and prominently the sun to track the position of sky or position of objects in the sky. They used just shadows and whatever positional astronomy. In Venu Bapu Solar Observatory, so basically they do Venu Bapu Solar is not a solar observatory. Venu Bapu Observatory is in Kavlur. So Kodaikanal is the solar observatory. In solar observatory, we have big telescopes that study the sun and sun's composition in different wavelengths. Then there is this Venu Bapu or other modern observatories. They have big telescopes and different sensors put in place, CCDs and spectrometers to study the composition of light. So basically what we are studying is the component or composition of light. So you can say traditional astronomy all has to do with the position of light, right? We don't care whether light is blue or green or red, but in modern astronomy we do study the blue, green or color of light, and now we have moved beyond that. We even study infrared, ultraviolet, as you see, and even beyond that, gravitational wave astronomy and all that is also there. Okay, is Muhurt in astrology scientific? So it's not scientific, as in there is no scientific basis of it being auspicious or inauspicious. There is a mathematical formula given to it. So all in my app there are many muhurtas. Obviously there is calculation algorithm to find it, but yeah, there is no scientific basis of any of them being auspicious or inauspicious. Deepak's question is, tell about some historical places or National Institute for college student industrial visit exploring astronomy. See, again, there are very different things. So there are many modern observatories. For example, there is Venu Bapu Observatory in Kavlur. Then there is in Nainital, there is ARIES, Aryabhat Research Institute in Educational, I forgot the full form, but there is an observatory in Nainital, and they have an observatory in Devsthal. So you would the biggest telescope, optical telescope we have in Asia is in Devsthal, that is operated by ARIES, Nainital. Then there is Udaipur also has an observatory. Kodaikanal is a solar observatory. Then there is something in I think Mount Abu also solar observatory. Mount Abu is also a small observatory. Then Hanle, yeah, Hanle is the most important one. So Hanle is operated by IIA, Indian Institute of Astrophysics. So Venu Bapu also managed by IIA, and Hanle is the best sky you can see from India. So that's a dry desert in Ladakh, and where we have our I think two or three many instruments are there. The telescope there is not that big, but it's the best sky and the best view possible. So that is Hanle. Then I think I've covered most of the astronomical modern observatories. Then there are 5 Jantar Mantars. All of them have similar yantras. If you go to Jaipur or Delhi, you will be able to see most of the instruments there. The other 3 have very, I think, less number of instruments. So that is more of an historical thing that you can visit for seeing what the shadow measurements could do. We can what sort of astronomy we can do with shadow measurements. So that is only thing that you can do in Jantar Mantar. Okay, yeah. Any more questions? If you asked previously, you can ask again. I'm not scrolled on previously. There might have been previous questions. Surya Siddhanta, authentic resource for further reading. So Indian astronomy is very vast. The problem is there are books for that. For example, I think there are many books on Indian astronomy by S. Balakrishna Rao in English. So otherwise, the problem is all of them are very heavy in Sanskrit and jargon. So even I am not well versed in Sanskrit that much. So for example, Surya Siddhanta, you'll find the original treatise in Sanskrit with translation. And obviously, if you are not well versed in Sanskrit, you'll find a book with English translation. But again, then again, these concepts might not be very easy to grasp very easily. So better to study bit of modern astronomy first. Modern in the sense that you can use stellarium and planetarium and actually observe the stars and planets in the night sky, get idea of the coordinate system and all, and see how it moves. For example, the stories that I mentioned of Dhrutara and all that. So when you get basic idea of that and basic idea of motion of the planets, then you can somehow grasp the concepts of Indian astronomy when you read those books. Okay, yeah. So okay, any more questions?
I suppose, sir, there is no question.
Okay, thank you.
So thank you, sir, for this wonderful session. A lot of myths has been broken now. Okay, I agreed with some of the facts with the astronomy and astrology. Okay, so now it's broken some of the myths. Okay,
Yeah.
because in my family there are some Jyotish, so I also believe in some things, but now it's
Yeah.
totally understood. So I like to the audience, just turn on your camera so that we can have a snapshot with this. So everyone, just turn on your cameras. So yeah, everyone, yeah, we have everyone. Okay, almost. I guess my camera is off now. No, it's fine. So happy World Space Week, guys. Okay, just smile. Okay.
Okay, thank you. Thank you, everyone.
Thank you, sir. Thank you, sir, for joining the
Thank you,
session.
sir. Thank you, sir.
Thank you.
So